Okay, so I've only got 2 slides because I'm going to be stepping through a bunch of things that are online in my browser tabs. So just this presentation by me. So I'm the ICS webmaster, as mentioned. I've got a position at the Australian National University as well, and I spend most of my time working for a private company that deals with semantic web things. The outline for today is for this piece is a bit more about the ICS website and how that relates to, in the second point, future plans for data-driven content. So that gets into our semantic web area. Just a very quick couple of points about CGI and geo-organizations vocabulary systems, which I've had a bit to do with, and their alignment with other systems. And then finally, a little thought piece with Steve Richard. And I don't actually know if Steve is on the call. I've been looking for him, but a discussion about some proposals about the geologic timescale, both the systems and the modeling. And of course, that's a semantic web version of it. Okay, so Phil already showed the 17 commissions or sub-commissions of the ICS. And here is a little project plan online, just showing as we're transferring existing sub-commission websites into a sort of single format. So what we're doing is we're working with each sub-commission in turn to bring their site into a sort of alignment using the same sort of templates and structures as our other sites. And the reason we're doing this is that the 17 or so sub-commissions have got quite different levels of information and different styles of website. We want to bring it all in together so that we can eventually do further data harmonization. Things like if a sub-commission wishes to have its GSSP information presented on its web page, it would be great if that information was synchronized with the main ICS information. So this is just a status chart we're up to. You can see, for instance, that the Neogenes website, let's click on that. That's been transferred to a system which is a bit garishly yellow, but it is kind of structurally similar to the main ICS website. Okay. Oops, I've gone back too many things. Okay, so now just a couple of other points on, so that's the major project. The major project is to work with each sub-commission and transfer their website across to the new format. But just looking at the code repositories that we've got in the ICS sort of system, there are a series of other individual ones, and I'm going to just show you those because they all have some relation to the sort of semantic tasks that we want to be dealing with. So let's just click through those. There is the actual chart page itself, and that's on our main website, and Phil's showing you the latest chart. And then we have some variants of the chart. So we have the official PDF chart issues, and you can see links to those here. And then we have some sort of experimental versions of this. Let's go to one here. Oh, there we go. So this is a more interactive version of the chart. It's not really official in any way, but you can click on elements of the chart and you can see information here. Now this information is derived from the semantic web version of the time scale, but it's not synchronized. So that's, I'll get to a bit more detail about that. And then just some other bits and pieces. Phil already mentioned the GSSP information, and we've got tables and tables of information here. And it's certainly a medium-term goal to translate that from web page content into data, into an actual database that then powers this web page. And part of the jiggling with ICS websites has been to make that easier. So we've got a fairly standard set of tables and so on. It's going to be quite easy, I think, to turn that into a database. The last one, of course, is the stratigraphic guide. We have a copy of that, and that contains links and all kinds of things, which again would form a kind of a set of backgrounding information to the chart. Okay, so just to recap then, we've been doing very simple web work to bring all of the ICS sub-commission websites into the same system, but it is with a goal of unifying the data and the structures there. Okay, now just a couple of points on the CGI vocabulary system. So the CGI has maintained vocabularies that support Earth Resource ML and GSI-ML for some time. Those systems are hosted by Geoscience Australia, and the vocabulary delivery system, of course, delivers semantic web versions of the vocabularies. So here we're looking at the list of GSI-ML and then Earth Resource ML vocabularies. And we can click through any of those vocabularies and see their content. So if you haven't been to the vocabulary page, please have a look. What you're seeing here is an HTML version of the content, but there are also machine readable versions there as well. And the tool that you're looking at here provides access to all of that information. Now, one piece of work that is external to the ICS work that I'm involved with is to update the vocabulary systems at CGI and elsewhere, and I'll show you those elsewhere ones in a minute. But essentially what's happening here is the tool that is used to deliver these vocabularies it's an open source tool. It was developed mostly for geological vocabularies. And we have a number of organizations that use this tool and have implemented projects to not only implement the tool, but also to extend it. So here you see CGI's vocabulary, and here's the next version of it. It looks very similar, but it's got some additional features. The Australian government's shared vocabularies between its constituent geological surveys is the Ausgen Network's GGIC vocabularies, that's the set here. And then if we look at the Queensland Geological Survey, they've got 80 or so vocabularies, again, delivered by the same system. Now, the next geological survey in Australia to implement a system like this is the Geological Survey of Western Australia. They'll implement the same system, and they're funding yet another module, and the module that they're funding will allow for cross vocabulary system searching. So you'll be able to go to search for a vocabulary and not only access the content in this system, but in also other systems that we've synchronized with it. So that should allow, in Australia, all the Australian geoscience organizations to search across each other's content, and then also the CGI vocabularies. And of course, it will allow the CGI vocabularies to back search into those Australian ones and additional sources of vocabularies as they're identified. And as long as they kind of reasonably similar to the types of vocabularies that we're interested in. So for instance, a non-geological source of vocabularies that might be of interest is the British Oceanographic Data Centre's vocabularies. They have a lot of scientific vocabularies, some of which may be relevant to geology. And so we would be able to search that corpus of vocabularies as well. So those are the kind of steps in the continuous, further rollout and continuous upgrading of the vocabulary systems. And again, all of these vocabularies are both available in human and machine readable form, in semantic web form. And these vocabularies that you're seeing here, these are all SCOS style vocabularies. Okay, so that's that short update there on the vocabulary systems. I should also mention, I just have to move my browser over because Zoom gets in the way. Those vocabularies and the tooling that's used is very related to the tooling that is used that I'm showing on the screen here. This is just a list of floods. It's nothing directly related to geoscience, but this tool that delivers this information, which has been prototyped for Geoscience Australia, it uses international standards to do with spatial data, the OGC API, and the tooling that is used here is very similar to our vocabulary systems. So much so that we'll be able to deliver content that's not vocabulary content in a way that's similar to this for other purposes. So we could deliver, for instance, databases of stratigraphic units online according to the Loop 3D ontology, say, using this tooling. And another upgrade in the vocabulary systems that CGI implements is to align the backend, the technical backends, with the vocabulary systems with this kind of system. So very invisible to day-to-day use, but it makes the tooling support for our semantic web work better or easier. Okay, now the last thing I'm going to talk about is the proposed changes to the modeling and systems of the geological timescale. So the proposal, and this proposal is very new. So Steve, Richard, and I have only been talking about this recently, and we've yet to put these ideas to others. So please don't feel that there's anything formal or official about these proposals. But the proposal is that over on the left here, you see essentially how the current timescale ontology and data works. You've got a general time ontology. We've got a specific time scale ontology and a couple other bits and pieces. And then we've got a series of issuances, or whatever you want to call them, versions of the actual timescale data. So for 2004, 5, 6, and 7, and so on. Now, each of those timescales has the Jurassic in it, say, and the Jurassic in the 2005 data is of course the Jurassic time period as it was known in 2005. And that's okay, but we can think of a better way of doing this. And the proposal from Steve, which I support, is that in fact we inject another element into the system. So the proposal here is to retain the individual Jurassics, but to introduce a kind of master Jurassic, so the master geological time scale, where there's a time period known as the Jurassic that really doesn't contain any information. What it does do is it contains inbound links from all the other Jurassics out there. So as human time moves on, 2005, 6 up to 21, we issue new charts and we refine exactly what we mean by the Jurassic. And so what we're doing is we're better and better characterizing the theoretical Jurassic. So the master geological timescale would be one that would contain all the time periods that have ever been named by geologists, even the ones that have been deprecated. And we would be issuing new versions of the timescale, named year versions of those timescales to refine that. Not all the information, not all of the planning for this is known. We don't yet know, for instance, quite how to associate the individual Jurassics with this kind of theoretical Jurassic. But nevertheless, this is the proposal. And we have, in addition to this modeling update proposal, a couple of other proposals about how we would then deliver this information. So that's what I'm going to show you next, and then I'll be done. So this is essentially the style of visualization that we would expect to deliver this information with. So, oh, that's too far. So we have this master chart, data-driven chart of time epochs that have relations. So the Jurassic is after the Triassic, the Jurassic is before the Cretaceous, or whichever way around. And then we have these individual individual chart issuances that relate to this. And we would actually build up the database of the whole lot, and then ultimately provide a tool to provide you a visualization, just as you see here. You would actually see the charts, so you'd be able to layer them and to scroll around, and I'll indicate what that will look like in a second. Well, here it is. So what we would see is a tool that looks somewhat like the vocabulary delivery systems, but instead of delivering vocabularies, it would deliver timescales, and the timescales it would deliver would be the GTS master, the 2021, all the way down to 2005. When you clicked on one of those timescales, what would you see? I've taken a snippet of vocabulary content, but you would see a more natural rendering of the content of that timescale. So the time periods and so on would be printed out. Now, we do have a data-driven system for this at the moment, but it's not tuned for time artifact delivery. It's a general purpose vocabulary system, and it's quite difficult to deal with. We would also expect that such a tool would be able to do an interactive timescale as well. So we should be able to see something like the interactive chart I showed you before, but rather than being a one-time project that a student of mine generated, it would be a live rendering, as you see in the bottom right here, of whichever version of the timescale you're looking at, including the master. So you could click on the master one, and it would give you the kind of not the latest and greatest version of the timescale. Yeah. And then if you were to click inside one of those temporal elements in any one of those timescales, I've just taken, again, a screenshot of an existing term from a vocabulary, but essentially you would get whatever information we want to present about that. And of course, in the case of timescale information, it would be the actual fixed time beginnings and endings of that period, things that it contains, things that contain it, so greater and smaller time periods. It would also link through to literature. So when we take the information from the ICS website and elsewhere and actually build that provenance data set, we would link to it from the system. The last thing I'm going to click on then is just a visualization here. This is somewhat unrelated to timescale information, but what you're seeing is called a Sankey diagram. And this diagram is a specialized kind of diagram that's used to deliver provenance information often. So this is really just telling us how different categorizations of Australian government departments are related over time. This is a specialized visualization mechanism for provenance information. And I think what we're going to need to see to make a good use of our charts from data are not just slightly better modeling of the timescale data, but also improved visualizations of the data. So we do know that, again, one of them looks something like this. You can see the timescale here. You can change the time axes to logarithmic, linear time. You know, this really gives you a sense of perspective of how long these time periods are in relation to one another. But there may be others too. So we're looking for suggestions and requests for sensible ways to visualize timescales and their elements. Okay, Harvey, I think that's 15, 16 minutes or so. So I think I'm pretty much on time.
Thank you, Nick. And first, I want to ask Nick, are you hearing me?
Yes.
Good, and I hope everyone is hearing me. I happily have the meeting playing on my phone, and so we seem to be making things work. So is there discussion for Nick, please? Please go ahead and unmute and go ahead with discussion or questions for Nick.
I have a question.
Go ahead, Eric.
Hi, Nick. Thanks for the presentation. Very interesting. What about some of those time epoch or stages that might actually be removed from the chart and reappear after? I'm thinking of quaternary that have been removed at some point, I remember, and came back.
Yeah, there's a very good, I think there's a very good sort of version control way of dealing with this. So if you think of any other version control system out there, not necessarily to do with time or whatever, but if you have a version control mechanism like a file managing one, and you add things to it and you take them away, I mean, you won't see them in the latest one, the latest version of that. Or if you do see these things that have been removed, they'll be presented in a way that shows that they're kind of no longer valid. So I think in what we would see in this case is that the master timescale would be our best guess at what the timescale looks like. And it may be that something that has been removed does not appear there. I mean, it does in the sense that it's in the history of that object, but it's not there in the current version. And if what you were to do, and I think this is a visualization that we will definitely do, is that you'll be able to sort of scroll that back over time. What did the timescale look like in now? What about in 2010? What about in 2005? And if you move that scroller back, you'll see the quaternary appear wherever it does appear. But yes, we have the tooling to visualize knowledge graphs in this way. We can scroll back through them. One of the problems, of course, is that this tooling is not free. And so that's one of the things we have to consider. But there is a fair bit of tooling that is free. And what we may be able to do is to build specialized visualizers that will allow us to scroll back through this particular set of data and do that kind of thing. So that's what we're sort of working out. We're slowly beetling away at working out what we can deliver, effectively for the ICS and so on.
Very good. Go ahead, Blaine.
Yeah, if I could add something. This distinction between generic time concepts like Jurassic and specific ones like Jurassic 2017 is something we've been looking at deeply within the geoscience ontology work that we've been doing. And I think you've been discussing that with Steve, Nick.
Yes.
From those thoughts, the notion of quaternary is a concept that wouldn't go away. So it would be something that would be always present, but it may or may not be included in specific timescales. So from your, knowledge graph of geology, you wouldn't want to get rid of quaternary, but it may or may not be incorporated in some specific collections of times of concepts that are timescales, for example. So that's certainly the way that we'd look at it from the geoscience ontology point of view.
Yeah, I think a unified collection of timescale information with options is where we need to be. So at the moment, we have these charts, but for instance, different countries have their own country-specific charts and extensions and so on. And it would be nice to think that we could incorporate all of that in one, brought to you by the ICS kind of place and have all of those options. So yes, there'd be a way in which you would see this is the kind of the chart in a sequential set of time periods of a certain sort. This is a slightly different one. You could even, and my hope in fact is to be able to build a visualization mechanism where what you actually do is you select which of the many timelines would I like to see presented sort of together, and you would go check. You would actually see more than one there in a kind of a probably left to right, and then a scrolling window. You'd actually be able to scroll back in time and see here's the the 2010 chart over the 2005 one. What are the differences? And then maybe also here's a local chart or whatever. And actually you'll be able to choose what you visualized. I mean, that's quite advanced visualization, but the data is not enormous, so it's quite possible. Yeah.
Very good. And Nick, are you able to see the chat?
Yes, I can.
Why don't you go ahead and react to the chat?
Okay, so Rachel Walcott's asked, one suggestion is visualizing timescales relative to the amount of data or quality of data for each period. Well, I mean, we would be able to do something like that if we, for instance, said, here is the timescale, and we could alter the display of those things based on how certain we are about the time fixity of that object, you know, whether we've got GSSPs assigned to both ends of it, that sort of thing. And yeah, you know, this is a well-referenced one, this is not a well-referenced one. So probably what we'll do is we'll put up a candidate or two of this sort of time presentation system and visualizations, and then really ask for feedback on that. So if that's the kind of thing that people really want to see, it would be important to know which of these things has more kind of academic backing than another. Then we might, you know, provide display options on that basis. But yes, the knowledge graph approach should allow us to really incorporate anything.
Right, thank you.
Very good. Okay, why don't we proceed with our program in a minute? However, does anyone have one final bit of discussion for Nick?
So
good.
just a quick question from Ed, the BGS. So I missed at the beginning. Did you say, is that API you've developed, that tool, is that on GitHub, on the Surround Australia GitHub?
I'll have to check which one you meant. So the timescale presentation tool is getting there. It's not quite up to speed yet. What we're actually doing.
Sorry, the
other one.
The flood dots around Australia.
Yes.
Yeah.
Yes, it is. Yes, Ed, I'll send you that one. Yeah, that's an open source implementation of the OGC API for spatial data. And yeah, in the end, the back end of VocPres in the next version, and that thing will be, you know, 80% the same.
Okay, grand. All right, thanks very much.